Splines are flexible objects that you can shape to conform to any curved surface. In the Pottery 1 project file, you will draw the profile of this Greek vase with a spline object. To begin, go up to the Draw panel and open its Slide Out. There are two different methods for creating splines, the Fit method and the CV method. CV stands for Control Vertex. And as the icon suggests, the points that you click don't necessarily reside on the spline with a CV. We'll see that in a moment. But first, let's create a spline using the Fit method. All the points in the Fit method reside on the spline itself. I'll click this tool and zoom in to the top of the vase. Click the top corner and then enter the next point here. Just keep going, clicking points along the profile of the vase. Don't worry that the spline doesn't appear to fit the curve yet. We'll come back and edit the spline later so that it does. Let's not worry about trying to represent the handles. Instead, we'll focus on the curve of the vase. Images disappear temporarily while you're panning. I'll pan up by dragging the mouse wheel and click some more points here, right on the edge of the vase. I'll pan up by dragging the wheel, and we'll just come down here, click a few more points. Now, because this is a photograph that is underlaid in AutoCAD, we don't have a true representation of the elevation of this object. Instead, we have to kind of guess at how this base would look in perspective. I'll click about here, have it go down, and then I'll have it go over to some imaginary point here in the middle, about here. Then I'll press Enter to end the spline command. I'll double-click the wheel to zoom extents, and let's try the Spline CV method on the right edge of the vase. Expand the Draw panel and click the Spline CV tool. Then zoom into the top, right edge, click the first point about here, and just work your way down. Now this is a little bit different. You'll see a dashed white line appear. This is the spline lattice that you're drawing. The red line doesn't actually follow the curvature of the vase. Instead, it's the lattice that does. It's a series of control points that you're clicking, which are on the edge of the vase. So because of this, the CV method isn't the best one when you're tracing edges like this in a photo. See, the red line is inboard of the actual edge of the vase. I'll come down here and just complete what I started. About there, and press Enter. Now I'll double-click the mouse again to zoom extents. Now of these two, I think I like the left spline better because it more closely matches the shape of the vase. Now I'll select it, and you can see the grips appear. These are the fit points, the actual points that I clicked earlier. If you double-click the spline itself, you automatically launch the Spline Edit command. And here you can use some of the options to change the shape of the spline. In particular, I'd like to introduce a kink into the fit data. So I'll use the fit data option, and then I'll click the kink option. As I move the cursor, you can see an X appear on the spline. I'd like a kink to appear right about here. I'll click, and the kink exists. It's hard to see that at this point, but just one click is all it takes to introduce a kink. Then I'll press Enter for exit, Enter again for exit, and enter a third time to exit the Spline Edit command. Then I'll come up here and select the object again, and I'll zoom in. You can see an additional fit point exists right here. That's the kink. I'll stretch this point by clicking on it and moving it. And now we have a curvature discontinuity here, and that's also known as a kink. This allowed me to have this sharp edge. Now, I could more closely match these fit points to the shape of the vase just by moving each fit point one at a time. But there's a more efficient way to do this, and that is to use this multifunctional grip to change the spline from a fit spline to a CV spline. When you do this, it doesn't change the shape of the existing spline. It merely changes where the grips are located. Now we have a CV spline. It works the same as this other one over here. But we shaped it initially using fit point method. Now I can come in here and move these CVs around, and it gives me additional finer control over the placement of the curve. I can move these around, and by positioning them just so, I can try to match the curvature to the vase. Now here I can't quite get it right. It's not really wanting to curve as much as I'd like it to. And so what I'll do is double-click on the spline to launch the Spline Edit command. And this time, I'll use the Edit Vertex option. And then I'll use the Weight option. To change the weight of a particular CV, you have to first select the CV. And you do this sequentially. The default option here says N, which means next. So I'll just press Enter, and this CV is highlighted. Press Enter again, the next one is highlighted. Keep pressing Enter until you get to the CV that you're interested in, namely this one. Zoom in, and then you can enter a new weight value. All the CVs start with a weight of 1 by default. Let's try a weight of 2. I'll just type in 2, Enter. And you can see that the spline is pulled closer to the CV. If I enter a weight of 0.5, the spline is pushed further away from the CV. So in this case, it looks like a value of maybe 2 or maybe 1.7 would be better in this case. It's a little bit closer to the curvature here in the photograph. So in this way, you can really dial in your spline object to match just about any curved surface. Now to get out of this command, we have to use the Exit option, which is not the default. And then again, Exit, and exit a third time to get back to the command line. In this lesson, you have learned how to create both fit point and CV splines, and have understood their differences and particular advantages. In addition, you used the Spline Edit command to create a kink at a chosen point and added weight to a particular CV.